So howdy.
Hello.
We got to see all these little things. You have little toys for us to see.
Yeah, I do.
This is Limor Freed. Tell us about Adafruit before we begin.
Totally. So my name is Limor, and I'm the founder and lead engineer at Adafruit Industries, which is actually really
Is it Ada or Ada?
It doesn't matter. It's cool.
I feel horrible.
No.
All the time.
I call you Johan Biegs, so it's fine.
Actually, I am Johan Biegs.
Yeah.
I have a special alter ego.
But we're actually in Soho, so we're really nearby, which is nice. I got to take the train here, took the CE. And we're an electronic manufacturing company here in Manhattan. We're probably one of the only ones. I keep looking for others, but we're actually doing electronic design, research, and manufacturing in Soho.
Now, I find software entrepreneurship boring. So I think what you have
You shouldn't say that here.
Oh, sorry.
They can hear us.
So all the stuff that you have in your bag is really cool, and we're going to show them, and they're going to become hardware entrepreneurs. So what's in there? Show us.
Okay, so wow, you just want to go straight to the toys.
I want to go into the toys.
Okay, that's cool. Okay, so we did a video recently, and I'm sure you still have nightmares about the plushy capacitor. So one of the things that we do at Adafruit is we try to educate people about electronics and teach them how to become electrical engineers, makers, do stuff with electronics that surround you. I mean, you have electronics in your pocket, you have some on your lap right now, but what's in it? How does it work? How do you build stuff? And so we're trying to get people familiar and comfortable with electronic components at really young ages, so we have little plushies. This is a plushie resistor.
So this is a sort of a hot dog? What is this?
No, this is Mo the resistor. And the resistor is one of the most common electronic components, and it's got two electrical leads. And when voltage is applied across it, current goes through, and it's how LEDs light up.
Now this is one of the questions. How can I teach my infant son, who's like basically sucking on this thing right now? He has it at home.
Yeah.
Not
it's like a hot dog flavor.
It's
probably shouldn't have put the hot dog sauce on.
How do I tell my son what this is? What am I supposed to say?
Well, I think like at a certain age, they just want to be comfortable with it, and I think almost everybody here probably when they were a kid, they'd love to take apart stuff. And parents probably like, stop taking apart the VCR. But that's how we learn. We take things apart and we understand them, and that's how open source software works too, right? The reason open source software is so instrumental in helping people learn how to program is because you can dig in, open it up. What's a for loop? What's an if statement? How does you do structures in this programming language? And that's kind of what we do with plushies, educational efforts, and open source hardware, making it easy for people to open the box. Because like the tablet you have or the cell phone I have, you can't open them so much anymore. They're glued shut, or the parts are so small like you can't understand them. So we have to sort of make them like big and plushy.
So presumably I don't want my son to understand that capacitors can be put in your mouth.
Well, you probably don't want to chew on them, no, but ages like 3 up.
Okay.
But the idea of getting people familiar with these elements is really important so that they're not scared of them, so that if they do have to repair something and they open up their television, they're like, after waiting a while to make sure that any capacitors are discharged, they can see, oh, here's all those components I'm familiar with, so then when they go to school and maybe they take a class in it, they're not scared. It isn't shocking, literally.
All right, so what other toys do you have?
Oh, sure.
I'll put him over here.
Yeah, I just have a lot of toys. So this is a coloring book that we recently did, and it's called E is for electronics. I want to make sure that the video can see it. And it's a coloring book for electronics, so A is for ampere, and B is for battery, and C is for capacitor, just like the capacitor you saw, and D is for diode. It goes all the way to Z is for Zener, which is my favorite. Luckily, there's something, there's an electronic part for every letter of the alphabet. And this is another thing where we want to get kids coloring and familiar with all these electronic words. And this is a Creative Commons download, so a lot of people just print this out and share it with their kids, and they can print out multiple copies if the first one didn't turn out.
So you guys are in a very specific business. You're in a specific business of selling electronics kits, obviously.
Yeah.
But you're also in this business of producing open source content to make electronics better.
Yeah.
And where do you guys see yourselves? Are you educators? Are you salespeople? Are you what is the open source portion of the business? How does that change the revenue generating portion?
Well, I like to say that Adafruit is a tutorial company and an educational company, and we have a gift shop at the end. So we have a lot of tutorials and projects and like this coloring book. And you can buy the coloring book off of our store if you want, or you can print it out, or you can buy these plushies if you want, or some people actually just made their own plushies using the patterns we put up on our website, the CAD files. But the idea is that getting people comfortable with electronics, because personally, that's what I want. I want to make a world where everyone is a maker, everyone's creative with electronics, people are building stuff, they're having fun. Electronics isn't this scary, weird thing that, I have to go to school for 8 years and be really good at calculus to do. I want it to be something everybody can do. And that's what the Adafruit goal is. And then the Adafruit store is where we sell tools and components and project packs. So some of the projects that will document, like, here's how you can build your own light-up tie, for example, which is in this bag. And then you can follow all our plans, and it's all open source. You could build it without having to buy anything from us. You can download the CAD files. You can download the bill of materials, build it yourself. But most of the time, people don't want to go and fabricate PCBs and like solder all these components. They want to get some of the parts ready to go so they can just sort of get creative, get fun. Just like if you're learning to paint, you can make your own paints. It's possible. Get pigments, get oils, mix them together. But you probably would rather just go to the store, get a canvas, get all the brushes that you need, and get started. Then later on, if you need to, make your own tools.
I mean, it seems like there's been a sea change over the past few years. I was talking to a guy in Shenzhen a few years ago. I told him about MakerBot and how it's open source, and he said he didn't understand that because he's used to making 100,000 widgets on a closed source model and trying to sell those widgets. What has changed in the past, even intervening 2 years, that's made your idea profitable, I suppose?
Well, what I like to tell people when we talk about open source, and there's actually an open source conference coming really soon to Boston, which is nearby here, the Open Source Hardware Association. I can't remember the name of the conference, but it's in Boston in September. And hundreds of people attend. And so this is a really interesting time to see what open source software, which many people are familiar with open source software. Every single company in the world uses open source software. I would not believe anyone who said we don't have a stitch of open source software anywhere. Every company has Linux or Apache or has Firefox or uses WebKit or an open source programming language. And so the open source software has been so instrumental in making it easy for companies to start up so fast. Anyone who wants to start up a software-based company can do so quickly because of all the work that's been done in open source software. And I really like that because it's powerful, right? It gets people started. Why should everybody write their own web browser? Why should everybody write their own programming language or framework when they can use something that already exists? So that's kind of what we're trying to do with open source hardware. So like software, you have the source code that's available. With hardware, you would have the bill of materials available, the CAD files. And each one of those may be open source under a license that makes sense for that kind of content, whether it's CAD or text, or some things can be copyrighted, some things can be patented, et cetera. And then people can build off of that work, and it's really cool. So one project that I worked on last year is I made a really efficient solar charger for batteries. So if you have a small solar panel and you want to charge a battery with it, there's actually no really good solutions for that in the DIY space. There's not enough money in it, and most people would rather just, if they're making a product, they'll just go with something that doesn't work quite well.
Is it the panel's fault or is it the battery's fault?
It's kind of just this intersection of like the cost is low enough that any efficiency gained is not worth the money. It's like if you have a huge multi-watt panel, it's worth it to spend $50 to get a really good converter. If you have a $3 panel, maybe not so much because of the cost. But I was personally interested in making a really efficient battery charger. I don't know. I was really bored one day. So I sat down and I designed this like solar charger. And I put it up in the store and some people bought it. And then some guy actually emailed us a couple months later and said, hey, I'm doing a Kickstarter and I want to do these portable solar chargers for developing countries and also people who are hiking or outside of the grid and need to charge their devices solar, and I really like your design. I'm going to base my design off yours. And I'm going to do a Kickstarter for like, $100,000 or something. And most people would be like, I hate you. Like, I can't believe you stole my thing, you jerk. But I was actually, this is awesome. This is a perfect example of, I don't want to go into that market. That's not something that interests me. But why should you slave away for months and try to get this working when you can just build something off of the work I already did? So we both benefit. And he got his Kickstarter running, and now he has like a product company. And I sell more of the DIY kits that I specialize in.
So you're able to sell the parts. So basically what the open source stuff was, you were selling support. Now you're essentially doing the same thing. You're selling parts for open source projects.
Yeah, and one of the things I like to tell people who are kind of like, how does it make sense that you give everything away and yet you're still selling these products? Well, what makes a customer happy isn't whether something is open source hardware or not. We do have customers who are really excited about open source hardware. But what makes a customer happy is pricing, availability, and support, the tutorials we have, the really great experience that they have. We ship within 4 hours. We have a really great shipping system in Soho where we're like super fast. And that's what people really like the most. So whether or not it's open source hardware would not, it benefits it, but it wouldn't take it away, right? It's like the things that will affect whether Adafruit is profitable is not whether our stuff is open source hardware, it's whether our customers are happy.
Mm-hmm. And that's actually amazing, because you guys are manufacturing, you have a pick and place machine in Manhattan, which I don't think they manufactured anything in Manhattan since like 1920. It's insane.
Well, what's interesting about Manhattan, and when we were looking to move, we moved to Varick Street in West Soho, is we had to actually do a lot of research about where we can move to, because we're doing manufacturing, site manufacturing. It has to be zoned appropriately, and there's a zoning code for it. And there are very few spots left in Manhattan that have this zoning. There's some parts of West Soho, there's some parts on the coastal areas, and actually a big chunk of Midtown. So actually there is a lot of manufacturing happening, but it's in the garment industry.
So apparel.
So apparel is still, there is not, to the extent that, all garments that are designed in New York are manufactured here. A lot of it still is done in larger factories, just isn't enough space. But New York was based on garment manufacturing, and there still is a lot of garment manufacturing and prototyping occurring in Midtown, which is great. We toured actually a couple of factories, buildings that had small workshop factories inside of them, and yeah, they're humming. They're manufacturing clothing. So it does still happen. There's also a lot of manufacturing in Long Island, in Queens, in Brooklyn, Staten Island.
So what's special about now, and what's special about New York that we are seeing a lot of this manufacturing? MakerBot is going to open a 36,000 square foot factory in a little bit down by the water. You guys just opened your new factory. Things are, for lack of a better word, changing in terms of moving over to New York, and people are building stuff here finally.
Well, New York is really great because it's a very dynamic, very creative city. Everywhere around here, all you see are fashion students, designers, artists, creatives. This is the city. This is what New York is based upon. And the government is also really excited to push for more manufacturing. Shapeways also opened a factory. I think they're on 14th Street. I don't know exactly the location. There's 3D printing is coming to New York. And one of the things that's interesting about rapid prototyping and manufacturing, as I do it and as companies like MakerBot and Shapeways and others that may do manufacturing in Manhattan do it, is you don't necessarily need as much space if you can divide up the work in different ways. For example, we recently did some injection mold design. So the design was done in-house at Adafruit, but we didn't buy an injection molding machine. We just outsourced that to a company in Canada who's really, really good at short-run manufacturing with injection molding. And you can do the same thing with circuit boards. We don't manufacture our own PCBs. It requires vats of chemicals. You have to recycle them a certain way, and it doesn't make sense for it to do it. But we work with a company in Colorado that does that. And so we can reach to all these other companies to help us with the manufacturing so that we can do that last step of design and tutorials and support, while getting assistance from other companies to do much of the larger scale manufacturing that, we're not going to be able to haul a 12 or 20 ton injection molding machine up to the 3rd floor.
And why'd you guys pick Canada? Why not just send all this stuff over to Asia and just have it all built over there?
That's a good question. And a lot of people who do manufacturing do think, the way to do it is to go to Shenzhen or Guangdong or Vietnam for clothing. And there's a lot of trade-offs. One of the trade-offs is, especially if you're starting out and you're a small company, is the risk is very high. Even though the pricing is lower, although it's not significantly lower, as the yuan has risen quite a bit recently, and also the working conditions and wages in Shenzhen especially have gone up quite a bit. So it's leveling out as a lot more. It's not like it was 10, 20 years ago, but that's good, right? It means that the people in Shenzhen are getting paid more, they're getting paid better, the competition is heating up there. The risk is that when you're sending something, and for many hardware designers, it's their baby. I mean, it's something that they've worked like 9 months on, and they're like, I'm going to give this to the world, this is my child, and you're kind of sending it off somewhere and hoping that people get it right. And that hope is a powerful, wonderful thing that will not stand in the face of
reality.
Reality. You know, when you send off files, anything that you don't specify will not be done. And as a person who's starting out manufacturing, you don't know what those things are. And they're just fascinating.
Do you have any horror stories, like when computer fell apart?
I haven't had to, but you know, I worked on designs where you know, I specified an inductor for a power supply, and you sent it off, and then the factory's like, well, we don't want to spend money on that one, so they swapped out another one, and it came back, and I told the guy I was designing it for, I said, there's no way they turned this on, and he said, how do you know? And I turned it on, it caught on fire, you know, because the inductor was way under specified. They didn't.
Maybe that's how it's supposed to work.
Yeah, I don't know.
Is that what you built?
No. It was actually a toy, right?
Okay.
So
Well,
it's like, yeah, you really want to make
kids
sure you
love
get
fire.
it right. That's true. That's true. Should have brought some fire with me.
Yeah.
So that's really risky, because unless you're actually physically going to the factory and living there, like literally in a sense of you are there every single day watching every article come off the line, you will not know what you're getting. And if you're very, very experienced, you might be able to do this, but you know, you see even massive companies like the Microsoft Xbox, you know, Red Ring of Death, which was a thermal problem with reflowing the, you know, BGAs, and when they got hot, like they twisted and popped off the board, and it's like a fracture, hairline fracture, but enough that it was a really big deal. And Microsoft, a really, really big company, and they had problems. So an individual in their basement, it's going to be even tougher. And then, you know, if there's a problem, sometimes you don't know until you get all 50,000 that you ordered. And so, to get to your question about why we often go with manufacturers in Canada or, you know, San Diego or New York or similar is we often have someone we know who's on the ground there, or we know the people there personally. With respect to the injection molder, we have an injection mold designer who has worked with this company for 20 years, and he knows them, and he'll go there and he'll actually take the pulls out, you know, the first pulls off the mold and check them and inspect them and test them, and not let them just go and make 50,000 and bill us, and then it's like they're wrong, because it happens, right? There's typos and mistakes. So that's something I would always suggest, even though it is always so tempting. You know, when you look at the pricing, it's like, well, you know, I can get it done here in the US for $250, or I can get it done in, you know, Shenzhen for like $1.25, that's half the cost, but that cost isn't, it's not a magical cost that you saved. You still have to pay that $1.25. It's just somewhere else. You don't know where that is.
Or you just buy a pick and place machine and put it in your Soho loft, which is
You can do
crazy.
that too. Yeah, we just bought a Samsung pick and place that is used to make cell phones. It's 28,000 components per hour. It's a pretty big machine, weighs like 2 tons. But you have to have a lot of capital for that. That's not for everybody. We like to do a lot of our pick and place in-house, but it only makes sense if you're at a certain scale. So, but I know a lot of people who start with hardware startups, entrepreneurs, and they begin by hand pick and placing. It's not glamorous, but actually if you go to some factories in Shenzhen, they do that too, right? I mean, like, you know, buy a machine or have like, you know, a 16-year-old place it by hand. Sometimes it's actually cheaper to have a 16-year-old place it by hand. So that's another thing why going to the factory is important, to see the conditions in which your stuff is getting made.
So we have like 1 minute left. Why don't you go through the more bag of toys?
Oh, sure. Totally. Oh, this is the tie I was talking about. So we do a lot of wearable electronics. So this is a project that we recently did, and the cool thing about this is it's no sewing involved. So when you speak, it acts like a VU meter. Hello. There you go.
I think you got it.
So this is the kind of project that we think is kind of fun to build, because it's electronics, and it's not something you can buy, but it's something that you can create, and you sew every LED in by hand, and then there's a microcontroller on the back and a little battery pack, and then you can kind of like rock it out with your LED tie.
If Josh had worn that, he could do the beatboxing and would have had a light show as well.
Yeah.
And then we also have a Raspberry Pi in there. I want to show everybody the Raspberry Pi.
Oh yeah, sure. So we also do a lot of stuff with the Raspberry Pi. It's an educational computer. platform. This is the injection molded case that we recently made in Canada. And I think this is really interesting because it's a $35 computer or $25 computer. And it brings the kind of electronic hacking that people used to do with the BBC Micro or the Apple II GS or Apple IIe back to kids now because, I think you probably grew up with an Apple II.
Sure. I had a Atari 800 XL.
Okay, cool. That's cool. Some people have Commodore 64. But that kind of joy of hacking something, and these are computers that you can actually connect sensors to. And this is kind of the future. We can learn electronics not just by typing, but also by connecting sensors and LEDs and whatever to your tie, and also to a computer on your desk. And it's so inexpensive that if you break it, it's not a big deal.
All right. Thank you very much. Let's all give Limor a hand.
Yay, my bag of tricks. You have to wear this.
Can we throw this into the audience?
Yes.
Okay, here comes a capacitor.
Resistor away!
We're not very good arms.
I feel pretty good.
All right. You want the coloring book?
Yeah, you get the coloring book.
Here we go.
I have to keep the tie, though.